And we are meeting Steam. It says we're streaming live on YouTube. Okay, now we're streaming live on YouTube. So welcome everybody. This is our June meeting of the RASC-Kingston Center, and I want to welcome everyone that's a guest that's not a member of Kingston and coming in from across country, as well as those who are on the YouTube channel. Generally, we have our meetings at Queen's University, but we're still not allowed into the location. Hopefully by September that might change. But in order to acknowledge the land, Queen's University, our past in-person meeting location, is situated on the territory of the Haudenosaunee and the Anishinaabe. And I just want to acknowledge that we are stewards of the land and that we respect our Indigenous people. So agenda, I haven't seen David Levy. Is he on? No, David's not on yet. So we're just going to go ahead and carry on. Susan, did you want to give an update on Fallen Stars 2022?
Yes, I would like to. And may I share my screen?
Yes,
okay.
You can.
Okay, super. And okay, so this is a pretty, I'm not sure what that green line is there, but I don't know whether you see that. Can everyone see my Fallen Stars slide?
Half of it. Yes.
Half of it. Oh, okay.
Just try stop sharing and reshare, see if that fixes it.
Okay.
No. Delete 0.
Any better? No, I don't think it is it?
That's
Okay, so I think, can you see the part that starts with the date?
Continued choppy trading is the best.
Yeah.
Correction, the Dow dropped 269 points.
Can you see the part that starts with September 23rd?
Yep.
Okay, well, that's really the important part. I'll just fill in all the rest. So from September 23rd to September 25th, that's Friday at 1 in the afternoon until Sunday noon that weekend. The Fallen Stars event is a rain or shine camping event, as it says right here on the slide. And it's going to be in Prince Edward County again. And it's a joint event with Kingston and Belleville centers. So you'll get 2 nights of observing, some short presentations, a swap table, solar observing during the day perhaps, and a catered dinner with door prizes. We do have a guest speaker this year, and it's Tom Deerhouse. He is going to speak on First Nations star lore. So if you don't know a lot about that, that'll be something new. So you can see the Kingston or the Belleville Center site for registration details. You can just download the registration form, fill it out, and scan it and email it if you like. And you can also e-transfer your fees this year. So you can do it all remotely, instantaneously, everything's good. So yeah, and the link underneath is there. It's RASC-Belleville.ca Fallen Stars. But if you just Google Belleville Fallen Stars, you'll be able to find it. So it's the registration for Fallen Stars 2022. And that's all I have to say.
Great. Thank you, Susan. Kevin had also put the link inside the chat so people can just automatically link from that if they want to do it tonight. And so great. Okay, I believe David Levy is now here. David, did you have something you wanted to introduce the center with?
Yes, I did. Can you hear me all right?
You're a bit fuzzy,
A little fuzzy.
a little
Well,
fuzzy.
let's see. I do have something that I'd like to share with you. Today it's a welcoming poem, and this one will be, it's a poetic piece of poetic prose written by Henry David Thoreau. And I got this from my brother, my younger brother, when I graduated from Acadia, and I've never forgotten it. It is from Walden. If a man does not keep pace with his companions, perhaps it is because he hears a different drummer. Let him step to the music which he hears, however measured or far away. And that's what I wanted to share with you today. Thank you, and back to you, Kim.
Great. Thank you, David. That was wonderful. Okay, next, what's happening this summer? Well, generally July and August, we take time off from our meetings, but we're still going to have our social times on Wednesdays. But the executive has decided to have on July 13th and August 10th, a meetup at Lake Ontario Park at 4:30 to 5 o'clock. And BYOM, so bring your own meal and a chair, and you can stay as long as you want. And we're going to sit around and have dinner in the park and chit chat and get caught up. Since we can't get into our Queen's University yet, well, at least we can get together and have our summer meal. So mark those on your calendars. It'll be the same night as we hold our regular meeting. So we keep everything in sync. And again, our social times will be on the other Wednesdays, will still be on Zoom, and that will continue through the summer months. So next up, we have John Hurley is going to give us an update on the GA. John?
Hello, everybody. The GA is coming up quickly. So I'd like to encourage everybody to go and register. It's available at the RASC.ca website. You can go in through the secure site login and receive member pricing. It is a very busy GA. It's coming up on June 24th. There's lots of good guest speakers. Some of you may remember Natalie Yolette from our Queen's experiences and the observing deck and all those fun events a few years ago. She will be giving the, I believe it's the Sawyer Hogg lecture this year. We have a Dr. Sarah Seeger. She's been in the news a lot. That should be very interesting. Dr. Robert Cardinal. We have a presentation being premiered at the GA, I believe, from this lady, Gina Paysan. It's an astronomical moment with the Canadian astronaut, Robert Thirsk. There will also be talks from Alan Dreyer, Dr. Jennifer Mather, and Chris Vaughn, and there's be some others. This is the tentative time schedule for various events going on Friday, Saturday, and Sunday. Saturday night, Helen Sawyer Hogg lecture. The annual general meeting is on the Sunday evening. And you don't have to buy tickets for the GA to attend the GA. To attend the GA, you need to buy a ticket. To attend the annual meeting and find out what the our board of directors has been up to and listen to and meet them, any member can attend that and vote on what's going on in the society. There is a link from the registration page for that also. Let's see, there's also a astrophotography contest and entries must begin June 20th. Your prize will be $50 gift certificate to the RASC store. And they have all kinds of nice categories that I'm sure many of you guys have all kinds of pictures on your hard drives just waiting to be shown off and gloated about. And of course, the registration process for sending in your photos. It should be a fun time. There's also going to be some mixing and matching. They have a online pub type room that people will be visiting through their avatars. And you'll be able to talk to people from coast to coast to coast. Our executive, our office staff, get to meet some of those new names we've been seeing in the email lists. It should be, like I say, it should be a very good evening. There is, like I say, I can't find it right now, but there is a link for going straight to the GA registration. And then there's the annual general meeting, which I do encourage everybody to attend to find out what's going on at national office and what direction society is going. There is a motion about our bylaw amendments, but there almost always is. So this is free. So definitely I encourage everybody to come. The GA and the annual general meeting. Going forward, the annual general meeting will not be part of the GA in following years, we hope. But I can talk about that at a later time. So that's all for now. Register and come and have some fun on the weekend online. This should be the last totally online GA. Hopefully by next year, we'll have an in-person event somewhere. There was some interest from a center or two, but I'm not sure what has happened about that yet. So thanks, Kim.
Hey, thanks, John. That's a great update. So yes, I definitely encourage everybody to log into the annual meeting and actually attend the GA and hear some great speakers. It's a great way to get into the gather town and meet everybody. Okay, so next up, we're going to do the introduction for our guest speaker, Rick Wagner. Rick is a life member of the RASC and a member of both Kingston and Ottawa. He is also on the science team of the RASC Remote Telescope, which is in California. Rick is an avid variable star observer whose observer code is WCR. And I tried to find out the number of observations that he had, but I couldn't, but I'm predicting it's at least in the thousands. He also runs the Boltwood telescope and the Hank scope at his home observatory. Plus, he's a tinkerer extraordinaire. So let's welcome Rick Wagner with his talk on basic image reduction.
Unmute me. Oh, I should turn off my video. Share the screen. Am I out? Slowly. All right, so many of us would like to take pictures of the night sky, either as pretty pictures or for science. So I thought I would talk about basic image reduction. So for those of you who don't image, I hope this talk will help you understand some of the jargon that we all spread about so much. And for those who are into imaging but aren't sure what they need to do or could be doing, I hope this will give you some pointers on some processing changes you may consider, either upwards or downwards in the amount of work you do. So I'm going to do this in a slightly different order than is often done in the books and so forth. So I'll start with dark current and simple dark frames, and then I'm going to cover bias or offset frames, scaled darks, flats, And finally, I'm going to close, I hope, with some hopeful and helpful ideas that may dispel any despair that the rest of this talk gives. Now, I should mention that everything I talk about here is applicable to CCD cameras, CMOS cameras, cooled or not, and DSLRs. So it's all useful information. So here's what we're looking to get. We go out with our telescope and our camera, and the camera should give me the target, the whole target, and nothing but the target. Unfortunately, that's not what we get. Here's a raw image of V0408 buoys. It's a high amplitude delta Scuti star in the constellation of Bootes that has some rather interesting features in its light curve. So I've started imaging that. Now you can see there's some flaws in this image. It's neither beautiful nor scientifically useful as it is. First of all, we can see, maybe you can see, it's kind of hard, but there's a faint line down the middle of the image. Goes right through one of my stars. Now that's clearly not something that's in the night sky. If you look carefully, you might notice that the left side, and especially the upper and lower left corners, are rather darker than the rest of the image. This is vignetting. And there are all these little round dots, little shadows. And finally, scattered over the whole image, I'm not sure, the noise reduction in Zoom may actually eliminate them all, but scattered over the whole image are hundreds or maybe even thousands of bright speckles that also clearly don't belong to the sky. So what is all this junk? Can we get rid of it? And if so, how do we do that? That is the technology of basic image reduction. Now notice that most amateurs call this image calibration, but that's incorrect. Reduction is the proper term. So here's the traditional image. So we have a quick refresher on CCD, well, astronomical cameras. Photons rain down on your camera and land in one of the pixels. Some fraction of these photons knock loose an electron, which gets collected and stored in the pixel. And at the end of the exposure, each pixel's electrons are read out from the chip. Now they generate a small voltage, which gets measured, and an analog to digital converter converts that to a number, analog to digital units, ADUs, which basically represents the number of electrons that were in the pixel, and hence the number of photons that hit the pixel during the exposure. So the first problem we're going to look at is dark current. In addition to the electrons knocked loose by the photons, we also have electrons that are knocked loose by the thermal motion of the atoms in the camera chip. Now these electrons get added to each pixel to the photon generated electrons. So they add an unwanted signal and also noise to our image. And even worse, some pixels are hot and they generate thermal electrons at much higher rates, and we get those bright speckles on our image. We often cool astronomical cameras as that reduces the thermal jiggling and reduces the dark current. Now, what's important about dark current is that the signal increases linearly with time. So I've done sort of some synthetic graphs. If we imagine a chip that's generating one thermal electron each second in each pixel, you can see here's a graph. It shows after a 100-second exposure, we should have 100 electrons from the dark current in our pixel. Here's a little video of a deep, deep crop of 5 of my darks. And you can see there's a lot of noise in the background. There's a lot of really bad hot pixels. And there's also 3 cosmic ray hits that flash by in a couple of the pictures. This is a very old camera. This is about an 18-year-old camera now, and has been used heavily, probably 250,000 pictures. So it's hopefully soon for the garbage. So if we stack all those dark images, dark frames together, we end up with a master simple dark. The simple dark is kind of my term. So you can see that the cosmic rays have disappeared. The bright line that was in my raw image is sort of visible just to the left of center. And in fact, there's even a second one beside it. And the dark, or the hot pixels rather, show up quite nicely. So we want to shoot dark frames. We shoot 10 of them or more and stack them to average out the noise. Now, what is a dark frame exactly? Well, basically it's an exposure that you take, same as you would take your sky pictures, but it's taken in the dark. A lot of cameras have light leaks, so the camera has to literally be in the dark. Your telescope should be capped, or the camera should be capped. The shutter should be closed. The other very important thing is that the camera should be at the same temperature it's going to be at when you're shooting your sky images, because the dark current depends critically on the temperature. And the dark frames should all be the same duration as the sky images you're going to shoot. And we stack those all together to form a master dark. And to apply a simple dark, you just subtract it from each of your sky images. Now, you notice that I said the dark frames have to have the same exposure as your science images. Well, that's great if you shoot all your sky images with one exposure. But if you shoot, like I do, images at 10 different exposures, I shoot anywhere from 20 seconds up to about 400 seconds. That means for every different exposure duration, I have to shoot 10 or more dark frames and stack them all. I would have to have probably 10 or 12 dark frames, and that's inconvenient, to put it mildly. What we really would like is some sort of a scaled dark. I could shoot a 100-second dark frame, then I can use that dark for my 100-second images. Then maybe I could divide it in 2 and use it for my 50-second exposures, divide the frame by 5, use it for my 20-second exposures. And that way I could manage with one dark frame, one master dark frame, and it would be able to serve for all my exposures. Unfortunately, that does not work. And the reason is the bias or offset. Now, because the analog to digital converter in your camera has electronic noise in it, it's possible when you read the camera out that you could have some pixels with negative values. That's not allowed. So the CCD camera manufacturers add a small constant voltage to the output of the camera. And this gets read as a small signal, as if there were some extra electrons in each pixel. Now, on CMOS cameras, you can actually adjust the offset and control what the bias level is. Now, ideally, the bias should be exactly the same for all the pixels. It should be exactly the same from image to image, regardless of the duration of the image, because this is something that happens when you read out the images. It's got nothing to do with the actual taking of the picture. Now, the trouble is that what you actually end up with is often a pattern in the bias, and we get read noise. So here's a graph of the bias level, the bias signal. We're assuming it's 500 ADUs. And you can see that, or 500 electrons rather. So it's 500 electrons whether I do a 0-second exposure or a 100-second exposure or anything in between. So here's an animation of, again, tight crop of 5 of my bias frames. You can see the 2 lines down the center of the image. So that's clearly coming from the bias, not from my dark frames. And of course, there's the read noise you can see simmering over the whole image. If we stack all those together, we can average down the noise. Now you can easily see the 2 lines. The noise is still visible, but it's actually reduced significantly. It looks worse because I've stretched this image somewhat differently to show up the lines. So what's the problem? How does this bias ruin our idea of scaling the darks? Well, when we take our simple dark frames, they actually consist of a bias frame or a bias signal and a dark signal. So at the end of 100 seconds, we get 500 electrons from the bias plus 100 electrons from the dark current for a total of 600. If I then divide that by 2, say for my 50-second exposure, 600 over 2 is 300, whereas you can see from the graph that really what I need is 550. The 500 of the bias plus half the dark current for a total of 550. So that gives us a hint as to how we go ahead and fix this. So we take a series of bias frames, again, 10 or more bias frames. These are exposures as short as possible as you can do with a camera. Most cameras, astronomical cameras, will actually do a 0-second exposure. Your DSLR, you can go with a 4,000th or an 8,000th, whatever the camera will do. In the dark, because it's a 0-second exposure, it's not quite as critical that it be absolutely dark. The camera should ideally be at the same temperature as when you're shooting. And again, because there's no thermal effects on this, it's less critical, but that's the ideal. And then we stack those to make a master bias frame. Then we shoot our long dark frames. And again, this exposure should be equal to the longest exposure we expect to make in our science images. So for me, like I occasionally shoot up to 400 seconds on the sky, so I shoot 400-second darks. I then subtract the master bias from all of the dark frames, and then I stack the bias subtracted darks to form a master dark. Then to apply these to my science images, I subtract the master bias from each image. I scale the master dark. In other words, I multiply it by the fraction of the exposure. So if this sky image is half the duration of my 400-second dark images, then I use a half of the master dark from my science images. So we've removed a bias, we've removed the dark current, but we're not done. What about all that vignetting and those dark spots that we saw? Dust specks in your optics cause the little shadows. Now these can be on the chip cover glass, on the camera window. A lot of cameras have a window, on your filters if you're using filters, or possibly even on a focal reducer or field corrector. Usually those are a little too far away to cause much of a trouble. But these all produce shadows on the image, which can be either ugly or reduce the apparent brightness of, say, a star that you're trying to measure. Vignetting is a darkening that's usually around the edges of the image, caused by the optics not giving fully illumination to the edges of the field. However, you should notice that some cassegrains actually have baffling that can actually cause vignetting in the center of the frame. Now, there are also, even if your optics are nice and clean and you don't have any vignetting, there can be variations in the sensitivity of different pixels. Some will have a lower quantum efficiency than others, and so they will give a higher or lower signal for the same level of light. Now, we need to correct these effects. But if we think back to the bias and dark currents, remember I said that these, there were these electrons that were added to the image, so we had to subtract a correction. In this case, these errors are all multiplicative. So for instance, a pixel may be 1.1 times more sensitive than its neighbor, or the corner of the frame only gets 0.9 times as much light as the center. So rather than subtracting a correction, we're going to need to divide by some sort of a reduction frame to fix these defects. So here's a flat frame from the Boltwood scope. This ideally is a picture of a perfectly flat light source. And so as a result, it gives exactly the same errors, flat errors, as are in my raw images. So if I divide this flat frame into my raw image, it should fix all those errors. So you can see the little dark shadows that were in the raw science image. Now, if you look closely, you can actually see that the little round shadows are actually donuts. They have a bright spot in the middle. That bright spot is actually the shadow of the secondary. So yes, we've learned now that the shadow of a shadow is a bright spot. And I should mention, of course, that refractors don't have a secondary mirror, so they just get round, I suppose, donut holes. These, let me see, I don't know if you can see them, but on the left-hand edge and just under the E in frame, there are two large donuts that are faintly visible. These two donuts are about 300 pixels wide. They're about 0.1% fainter than the surrounding area. And so I can measure that. And I should mention, in case you're interested, if you measure the size of a shadow or a donut on your frame, multiply it by the number of pixels, or the size of your pixel rather, and then multiply that by the focal ratio of your telescope, it tells you how far away from the chip your dust speck is. So the small dark shadows on my images, the dust is about 3/4 of a millimeter from the chip. So clearly that's going to be right on the glass that overlies the chip itself. And those two big donuts are about 11.5 millimeters up. So that's probably the window on the aperture to the camera itself rather than on the filter. And of course, the vignetting on this frame looks absolutely awful, but it's because of the way I stretched it. The left and bottom corners are actually only about 5% fainter than the brightest parts of the image. So flats are more than a bit of an art, and they can be really difficult. There's lots of discussion about how to do this. Now, why is there a problem? Well, first of all, how do you make a perfectly uniform light source? and it's big. It's got to cover the whole aperture of your telescope. Oh, but it shouldn't be too big because otherwise it may cause scattered light in your telescope. And that's something that may not be exactly the same as what we get from the night sky. It should be bright enough that we don't have to do terribly long exposures. It should be faint enough that we don't do really, really short exposures, particularly if you're using a camera with a shutter. Some of the shutters don't open and close all at the same time. And so you end up with, for instance, the corners will be darker than the center if you have like an iris shutter. And the light should be stable enough because we're going to take a whole bunch of flats, and ideally they should all be roughly the same signal so that they stack nicely. And on a more technical level, they should have a Lambertian distribution, which basically means they should be the same brightness in every angle. And they should also be spectrally similar to your targets. They should have the same color distribution of the light. So for example, a red filtered flat, if I take a flat with red light, it may not work very well with a hydrogen alpha object, even though I'm taking the hydrogen alpha object through the red filter, because the hydrogen alpha is a single spectral line as opposed to a broad band of red. I wouldn't worry about it. It's very small effects and really only important if you're going for the ultimate in precision. So what do we use for a light source? The four most common ones are light box, dome, a twilight, possibly with a t-shirt, and sky. So here's a light box. This is one I made for the 90 millimeter refractor. And you can see I've just taped it together out of foam core with masking tape, and runs off of 12 volts. And inside there's a couple of sheets of translucent plastic. Now you can see here, possibly in the corners, there are LEDs, and they are baffled. There are little holes between the LEDs and the translucent plastic. So the light shines up into the box and rattles around, bounces around all the insides of the box before it hits the plastic at the bottom. And then if we look into the end that the telescope sees, here's a second sheet of translucent plastic to further diffuse the light. And basically I just cut that hole the right size to just fit snugly on the aperture of the telescope. And the nice thing about this, for instance, is you can just add LEDs if you need more light, add blue LEDs if you need more blue light because your blue flats are taking too long. You can also do dome flats. This is something that a lot of the professionals do. So you basically have illumination around the aperture of your telescope. So here you can see on the Boltwood scope, I made a box with a plastic sheet, black, and then got a string of white Christmas LEDs, little battery powered string of lights, and drilled holes and stuck them through and glued them all in place. And they shine on a piece of polystyrene foam that's placed a foot or two in front of the telescope. What's really interesting about polystyrene is it's white, it's cheap, and it has Lambertian reflection. So these are easy to use. You can use them anytime. You just turn on the lights. It has to be reasonably dark so you don't get daylight illuminating your screen or the outsides of your box. but the light level is reasonably consistent. So you can take a whole series of flats. You can do them when it's raining out, whatever you want. So the next option, and this is what I use exclusively now, is called twilight flats. The twilight sky shortly after sunset is quite uniform if you look straight up. And it's nice because it's always there. It's uniform, it's bright, and it's free. And you don't have to build it. So to shoot twilight flats, you have to shoot, ideally, you shoot 5 degrees from the zenith on the opposite side of the sky from the setting sun or the rising sun. So you're where the sunset point is, and then go 5 degrees on the other side of zenith and take your pictures. Now, you have to be quick. The twilight is changing rapidly, and you only have about maybe 20 minutes in which to take all your flats. You have to shoot all your filters. If you're shooting filters, you have to shoot them in the right order. You have to start, like at sunset, you have to start with your darkest filter and then gradually work up to the lightest filter, so that as the light gets darker and darker, the flats don't get too dark. Now, I wrote a program, computer program, actually quite sophisticated, that calculates the light levels and predicts the light levels over the next little while. And it shoots all my flats, all in the correct order, and all at the proper exposures to keep the signals approximately the same. Now, I said the twilight's always there, except that, of course, it isn't. If it's cloudy out, it's got to be really clear, or you're going to get some clouds showing up in your flats. And then they're flat. Twilight is blue, so it's not at all the same color as most of your targets. That's not, I don't think that's all that critical. And because even with my program, the flats don't all end up at exactly the same level. So each one has to be normalized. In other words, they all have to be divided by something so they all have the same average brightness. And then you combine them all into a master flat. You can also do T-shirt flats. One of the problems with twilight flats is that stars will show up, particularly as the sky starts to get darker. So the idea is you just take a T-shirt, stretch it out over the aperture of your telescope. Maybe you need an extra large telescope or extra large T-shirt if you've got an extra large telescope. But it's kind of neat because it dims the sky. So for instance, if the sky is too bright, you can add 2 T-shirts, and it also removes the stars. Now, those of you who are skilled in the fabric arts will know that this is not in fact T-shirt material. This is actually woven cotton sheeting. Don't do that. I think the diffraction, because all the lines, all the threads are all going at right angles to each other and all parallel, I think it causes diffraction effects. And the flats I got with this thing are slightly weird, so I can't use them. So the final option is only borderline realistic, but I mention it to be thorough, is what's called a sky flat. If you median combine all your images, all your nighttime images, all the stars will disappear, because the stars are all in different places generally in each image. Now, on the other hand, the signal of the background, the sky background, is very faint, which means you need hundreds and hundreds of images if you're going to do this. And they have an added difficulty that if this is the kind of image you take, clearly the center of every image is going to be bright. The periphery of every image is going to be dark. You're never going to get a flat out of those kind of images. So this is really only worthwhile for photometry, astrometry, stuff like that, where you're taking relatively sparse star fields. So we have to shoot some flats. Shoot, say, 10 or more flats each filter. The ideal flat, the signal level is about half of the maximum. So for most camera, that's about 32,000 ADUs out of your maximum 65,000. And the way we work on that is, for instance, if we take 10 flats and each one has 25,000 electrons in each pixel, that means each pixel has collected a total of 250,000 electrons. If we take the square root of that, it means our signal to noise ratio is about 500, which sounds pretty good. But if you're trying to measure a star to 1,000th of a magnitude, that's not good enough. The important thing about shooting flats is you have to have the same optical system as you use for your sky images. And I mean identical. It means the filter has to be the same. Reducers. You can't rotate things. If a filter, you stick a filter in at a different rotation or rotate your camera a little bit. Even if you adjust the focus too much, it will change the pattern in the flat and you'll end up with artifacts in your pictures. When I first started off in astro imaging, there was something going on with my filter wheel, and all those little donut shadows all turned into little donut lumps that looked like they were protruding out of the image. It drove me crazy for several years. So reducing flats. Oh, wait a minute. You mean I have to reduce my flats before I use the flats? Yes. You're taking, maybe 10-second images with your camera. So there's a bias in there. There's potentially dark current. So for most uses, if you're taking reasonably short flats, you can subtract the master bias. If they're long flats, you may have to subtract a scaled dark from them. Or what some people do is they shoot what are called dark flats, which means you shoot a bunch of flats at the same, or darks rather, at the same exposure as your flats. So it gets rather complicated. It's much easier if you've got a cooled camera, keep your exposures short, then you'll be fine with subtracting the bias. And in fact, I've found that with the CMOS cameras nowadays, the biases are usually so good that you can just ignore them and do without. So, rather overwhelming load of technology. What do I have to do? What can I get away with? So the first point is to do what makes you happy. Balance your satisfaction with the final image against the work required to get there. If the little remaining defects really bug you, then, put in a little more effort into the reduction. If everything looks fine, maybe back off even a little. Depends a lot on what equipment you have. Yeah, I'll get into that later. If you're getting frustrated, simplify your process. Match your process against your goals. If you're trying to do millimagnitude photometry, you have to do everything I described here and probably more. Wait, more? That's why it's not so basic. If you're trying to get an image of a deep sky object that just shows more than you can see in the eyepiece, you may be able to get away without doing any reduction. And the important thing to remember is the software will handle most of the mechanics of all this work. You have to give it the information, you have to give it the frames it needs, but it's going to do all the hard work. So, at the simplest level, what to do? Nothing. It's a good place to start if you're a beginner especially. If you have a modern CMOS camera, the bias can be very uniform, so you can ignore it. If you're running it cold, like if it's a cooled camera, or you're shooting short exposures, the dark current might be so low, you don't need to bother with dark frames. If you keep your camera and filters, or maybe you're not even using filters, keep the camera clean so there's no dust bunnies. And if your scope provides a big enough image circle, bigger than your chip, so there's no vignetting or only minor vignetting, you may not have to bother with flats. So this is an easy way to start for beginners. Get some joy from your images before you get too stressed over some of the details. One concern is hot pixels. Because these hot pixels generate thermal electrons so much faster, you often, even in short exposures, you can end up with hot pixels. Now, some software, some processing software can find and eliminate them automatically. Mostly hot pixels are a single pixel. So if the software just goes through and corrects any single pixel bright spots. So you may not need to do dark frames. On the other hand, if your software can't do them, probably the easiest way to get rid of hot pixels is to just do the simple darks. You shoot dark frames of the same duration as your science images and just subtract the master dark. Medium effort is probably simple darks. Restrict yourself to just 1 or 2 exposure durations. So you don't need to do bias and darks. You can just do simple darks. Or stack them to create a master dark. And if your camera has a big chip or your scope has a small field, particularly this is often the case with Schmid-Cassegrains, especially if you have a focal reducer, you'll almost certainly get vignetting. And you're probably, I mean, not very many people are clean enough to have no dust on their optics. So you'll need to use flats. If you shoot at lots of different exposures and you want the highest quality images, then you have to do the full suite. You shoot a whole bunch of bias frames, create a master bias, subtract the bias from a whole bunch of dark frames, create a bias subtracted master dark. Then you use a bias subtracted master flat. You have to have a flat for each filter. Subtract the master bias from your raw image. Scale your master dark, subtract it from the raw image, and then divide by the flat. And that's almost everything you need to do if you want to get up to the ultimate level in quality. Any questions?
Oh, my brain hurts. Oh.
Yeah.
Amazing presentation. I need this in writing in front of me to go over 10 or 100 times to understand, to know what I have to do, and to go back to number 1, don't worry, be happy, do nothing.
Yes. I should write up something for Regulus so you can something relatively brief, because I mean this is all available in all of the books. Astronomical image processing for Windows has it all, but it has it scattered over 40 pages. So
it's all right, Kevin. It's been recorded.
Yeah, first-hand recommendation from you works more than all of those books.
Right. Okay.
So Rick, when I'm shooting my dark, sometimes what I'll do is I'll just set up my telescope, wait till it gets dark, cover the end, and then just run through a computer program which automatically collects them and then gives me an average dark, and that seems to work for me. But I'm always worried that light leaks in, but it doesn't seem to, and I'm just wondering if that's the way most people do it, because it only takes a couple minutes before you start for the night.
Yeah, it's basically, and this is a test I've done with each of my cameras, is I I shoot a couple of my normal 400-second dark frames during the afternoon, and then I shoot a couple at night in the dark. And if they're essentially identical, then I don't need to worry about it. But I found several of my cameras have very significant light leaks, and the daytime shots are significantly different. So then you have to do it in the dark. But so I would say in your case, maybe try and do, like one time, be extremely careful about dark, make sure there's no lights on in the house, maybe even wrap the camera in a black t-shirt, that kind of thing, so that you're sure this has got no light in it, and then compare that to your normal darks. And if they're close enough, that's all you need.
Yeah, because I used to do that. Used to just have the camera by itself and shoot my darks. But then that messes up whatever flat you had prepared, because now you got to put your camera in a different spot. So then you got to go ahead and.
Yeah, I often shoot my flats, or I'd rather shoot my bias and darks at a different time than when because I have a cooled camera. You see, so I can set the camera at -25 and shoot bias and darks, same as I would set the camera at -25 out under the stars. If you don't have a cooled camera, it does become more difficult, and shooting, some darks before you observe is a better idea, because then the camera's at, roughly the same temperature as you're going to be shooting at. And you might want to even think, if you were going sort of fairly long through the night, is, every hour or two, shoot a half a dozen darks, just, because the temperature's gone down, your camera's cooled a bit. You might get a slightly better dark. But again, if it's working for you, why mess around?
Okay, that is excellent, Rick. I think I'll just go with the not do anything. Thank you. All right. I guess we'll go on to our next speaker. So we'll go from the darks, and now we're going to go to the light, and we have Hank Sunspot. Hank, you're up.
Hello, everyone. Okay. Yeah, I don't have to do any darks because bright is my thing. So let's share screen, and I'm going to share this one, I believe. And the slideshow. Do we have a full face slideshow there? Or
Yes,
not?
we do.
We do. Okay, right. We are ready to go. Okay. Hank Sunspot from May 11th, June 7th. June 7th was yesterday. I don't do anything usually for the day of the presentation because it just gets a little too complicated. So this runs from last meeting to the night before this meeting. And it has been kind of a neat month. No, it's been kind of a weird. These two images by Kim show the sun in white light left and hydrogen alpha on the right on 2022-05-11. And AR 3007 is in the southeast. As you can see, if I drag over here, that's 3007. It went on to produce over a dozen flares, including 2 of which were M flares. And it was a nice sunspot grouping. It was quite fine. And on the right-hand side there, you see the solar prominences that Kim has caught, from hedgerows to, well, I don't know what I know that's not a flame really. I've kind of gotten away from all the names they have for them, but amazing differences. And even though the sun in white light, as I always say, doesn't look that great, sometimes the H alpha is what really tells the story. Now, during the week of May 15th, 20th, 21st, There were 8 M-class solar flares. This week or this month was really building to be awesome. Things were really looking up. And these flares were from 3010, 3014, 3017, and one unknown, which I believe that unknown was 3014 before it came around. Weather and schedule kind of sucked. So this is the only decent image of 3014, these two images here. And you can see on the right-hand side, the actual sunspot grouping. And on the left, you can see that grouping as well, but also the residual and extra energy pattern through the magnetic fields that is there. And especially to the right, that long magnetic field there. It's amazing how much more structure, excuse me, there is to these sunspot groupings in the H alpha rather than white light, and in magnetograms and everything else, there is much more as well. But if you compare the two sides here, the plage on the left-hand side of the right picture kind of compares to the plage on the left-hand side. And so it does in the bottom half as well. But in the sunspot groupings, where when, oddly enough, when the sunspot groups are straight on almost, you don't see the plage very often. It's very rare to be able to see, I think, the plage, or it takes a much better photography than what I'm into these days. And it's fascinating to see in H alpha how much more structure there is to it all. And also on the limb, the sunspot groupings that are coming or going away on the west-hand side. So next images were on the 23rd, and it shows 3014 nearing closer to the west limb and drifting away. And as travel across, it produced in total 26 C flares and 4 N flares. So it was a good active grouping for sure, and provided us with a lot of interesting flares. But as you can see also down in the left-hand side, the H alpha image, the long hedgerow style prominence on the southwest, as compared to there being absolutely nothing there in the white light. No sunspot groupings, no plage, no anything. So H alpha really shows you a lot more detail. These two images taken by our members Keith in H alpha on the left and Susan in a white light on the right were taken on May 29th. On this day, AR 3023, 24, and 25, which is not shown in these images. I tried to peg it in Keith's image on the left because it's a full disc, but without doing a full rotation and flip, I just couldn't match it up exactly because it was very close to the limb and didn't seem to show up. And sometimes, oddly enough, sunspots do not show up in H alpha. Their energy regions show, as you can see here on the right, these two spots of 24 and then 23. You can compare them here, 23 and 24, but the spots themselves do not come in really well. But these were really good images, and the image that Susan sent me originally, she wasn't too confident about it, but a little tweaking really brought out the sunspots really well. On June 4, there were 4 B-class solar flares. Oh my goodness, I'm so excited. There were 4 B-class solar flares. Well, yeah, that's about it, because as soon as 3014 left the solar disk, everything just died. Basically died off, became back to what we were over a year ago, 2 years ago in solar minimum, it absolutely dropped right off. But even though it did, take a look at this fly landing on the side of the sun here, just buzzed in and landed there. And like I say, H alpha, you got it. Always something interesting regardless. Now, you can see here that these two are aligned, these images, and try and match these sunspots. I believe the one which is 3023 is there. 3024 is below, but try and pick it out. If the etalons are not tuned to the spots themselves, which is something that Kim has shown to you quite often, the spots tend to disappear in themselves. The plage, look on the left-hand side of the right image, there's plage there and plage down there. And you have the plage here and plage in this area here. But the sunspots themselves can just be gone. Now, the solar cycle prediction, prediction, yeah, that's kind of like the teacup reader or anything else. Once again, solar cycle 25 is exceeding predictions. Sunspot numbers in May 2022 were the highest in almost 8 years. Now that's going right back pretty close to the last maximum. And that's where we should be. More than doubling the NOAA's official forecast. There is no longer any doubt that solar cycle 25 is on track to outperform its predecessor, historically weak solar cycle 24. And you take a look across this graph here. It's amazing the difference between prediction, which is the blue line, and the green curve is the average of all cycles. The red is the new prediction, which is incredibly above. You're looking at a difference here between maybe a 110 sunspot number to a 190 sunspot number. That's an incredible amount. And it's all, well, not all, but it's in part due to this new idea of the termination event, which happened December 2021, has changed the curve. And you can look that up at spaceweather.com with this address I've given here. But the current sunspots counts are becoming amazing. And even if the solar cycle 25 turns out to be merely average, it will still be much better than what was previously forecast. And I think they should just stay away from forecasting, because I think most often forecasting is just a point of people want to prove that they were right. Let's just go into it and go there and chart it and see where it goes. But they always want to forecast and say, and that's just like there was recently going to be a bright flurry of meteors and it didn't happen. And there were comets that were going to be naked eye and they didn't happen. Stop trying to hedge your bets and say what it's going to be. Just say, watch for it, and have astronomers do their thing. So a summer meeting month from the 11th to the 7th. And this has the previous month in brackets. Active regions were 24 this month, 20 last month. So 4 more active regions. Yet X flares, there were 0 X flares this month as compared to 5 last month. 13 M flares compared to 35 last month. And C flares, there were 131 compared to 229. And this has a lot to do with the fact that after 3014, and I don't know what significance that spot could have, went over the southwestern or went over the western limb, everything just died right off. We went into B-class flares, a very few C flares, only for about a week there, and then they totally disappeared. And the total flares for the month were 144 compared to 269. if you take what the first half of the month was, our meeting month, it was amazing. But this last half has brought it way down. So the sun is resting in this past 10 days. There have only been 5 flares above B level. And today, the 8th, the sunspot count became 0. This morning, there was 0 sunspots. And that hasn't happened for a long time. I didn't look up the specific date on it, but it hasn't happened for quite a while. The raw observatory imaging sessions, 14 this month, 13 last month. So it was a little better, one day better, and could have been even better than that, but scheduling sometimes gets in the way. But on the good news side, look at this. Later today, and this was around noon, the first image. This image was just before the meeting tonight. Look at that sunspot grouping right there in the south center of the sun. We've got a nice, tight, roundish grouping there, and it has grown well. It's not been numbered yet, but it's likely to be my morning our time. And we also have a nice bright plage coming on the left-hand side. And so we're looking at things really picking up. Also plays in the upper northeast as well. So that's my report for this month. And out there, take pictures. Susan, send me some more. And also Keith and anybody else. Get out there, send us some pictures so we can fill in more and show more what people see from day to day. Thank you.
Thank you, Hank. That is awesome. I was outside today and took some images. I haven't processed them yet, but there was a nice flare prominence that was coming off the top of the sun.
I got it this morning. I'm going to work on that tonight. So,
but I didn't.
Great.
I closed up the observatory about 11:30, so that spot came in after that. So it's nice to see because there was nothing this morning. Yeah. But I did catch the flash that was on both limbs.
Good.
Yeah.
That flare was I was going to say that flare was really faint, but it stuck way out.
Yes,
from
it did.
The rim.
Probably close to 100,000 kilometers.
Yeah, I didn't take any pictures, but I did. It did look pretty blank. But I saw that flare.
Can I ask a question? Hank, so with that increasing or at least stable number of flares and so on, what's the impact of that going to be on things like aurora and that kind of thing?
Well, the aurora thing is something we all hope for, certainly, and we expect, and it just seems to be a shot in the dark kind of thing, or a shot in the daylight. Often we've had some really big solar flares, but they've gone off to the one side or the other. And like, it's almost like there's something stopping solar flares from coming directly at Earth. Oh. And a spot will go across. It's huge, it's beta gamma, it's messed up, it's ready to explode. It will do very little. It'll drift over to the far side and then gone. It does increase our chances of aurora, absolutely, but it seems like it just doesn't happen. We haven't had really good aurora since what was it, 2004 or 7? I think that we've had really great aurora.
So there's a certain threshold of activity and also time as well.
Positioning, yeah, time and positioning, and being directly at the Earth, but also being, if the eruption was directly in the center of the sun, it's going to be basically coming our way.
Yeah.
If it blows straight on, but it can blow off to a diagonal, and it just messes everything up. But we have had some eruptions that have happened on the far side of the sun over the edge of the limb. And it's been absolutely fantastic. You've seen them. I've showed them in the last meetings. And then it comes around and just dies. And I hate to imply anything, but it's like there's this shield, your Star Trek force field around the Earth that they just never seem to hit towards us. But someday soon they will, and we will capture. Rosemary will be out there just taking pictures and getting those auroras, because we'd sure all love to see them. Thank you.
Okay, thanks.
Okay, that's great. Everybody just keep looking, keep going out and try to take some pictures of the sun, because as it is, it keeps changing every day. So next we have Rick Wagner, who's going to do what's up in the sky for June 2022.
I bet you Rick doesn't know that he's muted right now.
Hello, Rick. Birth to Rick.
You can do it, Rick. Your screen sharing is just fine. There you go.
There we go. There we go. All right. All right. Okay, so no local events, no BAA events that are available to us without flying to England. AVSO webinars, the members only talk on the 25th of June, Dr. Christoph Stanek talking about Assassin. This is the all-sky survey for supernovae, big science with small telescopes. And then on the 2nd of July, they'll have their regular how-to hour, which they've not set a topic for yet. Lennox and Addington Deep Sky Viewing Area, 24th and 25th of June has a laser-guided stargazing tour, their monthly event. On the 2nd of July, their astrophotographers assemble. And on the 9th of July, up close with the moon. North Frontenac Deep Sky Preserve on the 18th of June in the afternoon, unusually. The nearest star, our sun, sort of a Father's Day thing. Hours of darkness. There hardly are any. We're down to 3.5 hours of astronomical darkness. However, you can see in the numbers in the little table there that by the 1st of July, things are already starting to improve very slightly. In the sky in June, today, the minor planet 41 Daphne is at opposition, magnitude 9.8. 12th of June, the moon occults Delta Scorpii in the evening sky. And I haven't actually even checked to see if that's twilight or what, but anyway, should be fairly interesting. Delta Scorpii is quite a bright star. It's not often the moon occults bright stars. Full moon on the 14th. 16th June, Mercury is at greatest elongation west, and that gives us an opportunity for about a week or so to see the 5 easy naked eye planets in the dawn sky. And interestingly, as you move left from the sunrise point, they're in the proper order: Mercury, Venus, Mars, Jupiter, and Saturn. And then if you get out binoculars or a telescope, Uranus and Neptune are already also stuck in there somewhere. 21st of June, Mars is at perihelion. This is when Mars is at closest to the sun. So ideally, this is when you want to have an opposition, except that opposition isn't until, I think, December, by which time Mars will be somewhat further from the sun and not quite as large as it could be. 21st of June, last quarter moon, and also the summer solstice at 5 o'clock in the morning. The 21st to the 27th, we continue with the 5 easy naked eye planets plus Uranus, oops, I made a mistake, plus Neptune, plus the moon will be going by. I'll have a graphic of that later. New moon on the 28th. Minor planet Aquitania is at opposition on the 28th. 29th of June is an opportunity to see an extremely thin crescent moon, less than 23 hours old. In early July, the Earth is at aphelion on the 4th of July. It'd be interesting, all you solar imagers, compare your 4th of July images to your sort of early January images and see if you can actually detect the difference in size. 7th of July, first quarter moon, and 13th of July, the date of our picnic, full moon, also the largest in 2022. So here's the dawn planets as depicted by Stellarium. You can see the sun below the horizon on the left, the moon just next to Mercury, Venus below the Pleiades, then Uranus, be too faint to see naked eye, Mars, Jupiter, and then Saturn is well off to the right, actually past the meridian already by this point in the morning. And the 23-hour-old moon in Gemini, I don't know if Castor and Pollux will be bright enough to be visible, maybe in binoculars, and help guide you to find it low over the northwest horizon after sunset. Small bodies, K2 Pan-STARRS is a comet that was detected way out in the solar system, quite unusual. Looks like it's not going to be as bright as people were maybe hoping, but we can probably expect it somewhere around magnitude 9 through June. And on the 20th of June, it passes just southeast of the open cluster IC 4665. Then on the 28th of June, the asteroid 19844 2000 ST317, very catchy name, occults a 12.2 magnitude star with an even catchier name that I'm not even going to try and read out to you. Unfortunately, it's only an 8% likelihood of actually us seeing it. So you can see there's the path. The heaviest blue line is the predicted center of the path. The narrower blue lines are the predicted edges of the path, and the dashed red lines in the top right and lower left are the sort of 1 sigma error lines on the path. So it's quite a broad area and quite a narrow path. So only an 8% chance of actually seeing anything happen. That's what I have for next month.
Thank you, Rick. That is great.
Any questions?
Oh, okay. Next up, we're going to do the members observing report. So we'll do a roundtable on that. And let us start off with Elena.
I've just been getting up in the morning with binoculars, but no photographs or anything.
Looking at the planets?
Yes, looking at the planets.
It's amazing how much Jupiter and Mars have moved apart. Yeah. Okay, great. Thanks. John Hurley.
Yeah, I'm doing the same thing, getting up, getting the binoculars outside in the morning and going for a little hike down the hill so I can see the planets and trying to get a little bit of solar in once in a while. But the weather is making that interesting.
You could say that. Okay, Lori.
Yeah, I went out and was disappointed by the Tau Herculids. I did see about 9 definites and a few that I thought I saw, but I wasn't quite sure of. And I watched the lunar eclipse, and for my house, it actually wasn't too bad. I took a few pictures, but nothing special.
You got out observing. That's special. Okay, Susan.
I had a few very good nights. I got a fair bit of variable observing done, and I've been tackling the brighter variables, which I find very difficult. I like them a bit fainter. The bright ones, I just find them more difficult. Yes, I got out to see the eclipse and got some pictures, and I saw one of their Herculids before I fell asleep in my lounge chair, and that's it. But there have been very few opportunities, but I was able to make the most of them, and that's it.
Excellent. Thank you. Bernard Day.
Yes, no, I don't have any pictures or tonight. Just came on to hear Richard's talk there. We've been having a lot of cloud down this way. I'm right on them on the East Coast there. So, but we are expecting a few clear nights coming up. So hopefully, if we get on again, I might have something to show you.
Great. Excellent. Thank you. Okay, Brian McCracken.
So I didn't unmute myself. Nothing since the lunar eclipse photographs. Nothing else.
That was an excellent image. I saw it on Facebook. Excellent.
Thank you.
Beautiful. It's beautiful. Bruce Elliott, you had some pictures you wanted to show.
Can I just show screen here?
Yep.
Okay.
Okay, go ahead, Bruce.
Yeah. That's funny. It does. Is it okay? I'll see even. Yeah. Okay. Can you see that?
No, you haven't shared your screen yet.
Okay. Okay. All right. Here it is. Okay. Oh, here it is. Okay, there we go.
Okay, something's
You
coming.
see that?
Yay. Yes.
Oh, good. Yeah. So Janet and I decided to go to the to Desert Lake. We stayed at a cottage in nearby at Snug Harbor, and so we saw the moonrise. This one was taken at about 8:10 in the evenings, and so just a minute here. There we go. So there was a dock down on the water, so got some really nice reflection of, and an interesting perspective through the branches. This was my I did sort of a time lapse, and I got everything except just as it was getting to the moon being completely in the umbra. We had a clouding over, so I actually a friend of mine in Sydenham Lake area actually provided that picture right there. Yeah, and so then can you see the one down in the lower right here?
Yes, we can. Very nice composition.
So it has just a little sliver on it. And As we proceeded into the period of totality, I just took a broader picture, and just because it was really interesting to see how the stars started to become really bright as the moon was in a totally eclipsed stage. But you can see the clouds here made it difficult to really see anything as clear as I had earlier. But I was really happy to see this, because the speaker we had, was it a month ago, was saying suggesting that it'd be interesting to see just how bright the stars are in the sky. So yeah, that's what I wanted to share tonight.
That is excellent, Bruce. That's a nice compilation of lunar pictures that you took.
Thank you very much. Yeah, we had a lot of fun. It was sort of we had two cameras set up, and taking pictures from different angles at different times, and so it was kind of a fun way to spend the evening. Yeah.
Okay.
Okay.
That's excellent. Is that all you wanted to do tonight?
Yeah, I think so. I can just on the outreach side. I've been in touch with Kim. You and I have exchanged some emails on this, I think, as well. But in the progress of trying to find out with regard to the total eclipse in 2024, I'm on the one of the outreach committees that are trying to sort of organize this with Queens, and Kim is as well. And I guess the news we got today is that RASC central office has agreed, or is proposing to provide eclipse glasses for free. And we have to order them ahead of time. So we're in the process, as far as the committee is concerned, just trying to figure out how many we want to order. And I guess, Kim, your input is going to be very important there too. But the decision will be made, I guess, in the next, well, there you go. That's kind of what it is. The ones that come from RASC are going to have will have an emblem. Well, that's not the right, a crest. What do you call it?
A crest. Yeah. The brass crest. Yeah.
Right. Yeah. So it will be RASC Canada. And there's, I guess it's interesting, just learned this week, I just learned this week that there's a new outreach coordinator with RASC head office. It's somebody by the name of Samantha. Jenna was the previous. Jenna Hind was really excellent. And she's moved on to a different stage in her career, but Samantha, it seemed like she responded really quickly to the request for information, and she's really keen to help out. And if anyone in the group has some specific questions they want to ask about how the outreach might be eventually turning out, then she'd love to hear from us. Yeah, so I think that's about all I had to say on that. Kim, did you have more to add? Or?
No, that's good. Right now it's just collecting data, and we're waiting for some more information from Queens before we put in the order with the RASC for the solar glasses.
Yeah.
So we should probably hear back in a day or two. We have until July 20th to put the number in, so we're good. Yeah.
So it's a bit of time.
Yeah. Okay. That's great. Thanks, Bruce. Okay, next up is Carl. Nope. Okay. Fred.
I was out for the eclipse, and since I get up pretty early in the morning, I go out and have a gander at the planets and see if they're still moving, and they are. Looking forward to the lineup later in the month. in a week or two. I wrote about that in my column. I hope some of the readers actually get out there, and I think there's a lot of early risers there. I hope they get out and have what I think is quite a spectacular show, weather permitting.
Right.
All right.
Excellent. Okay, great. Thanks, Fred. Okay, next up is Getchen. No. Okay, Ken.
Yeah, I've got no pictures to show, but I have been out on, I looked at the solar eclipse, was out and took some pictures of the planet lineup in the morning sky, and was at a very nice outreach event on Lake Huron on Friday night. We set up our telescopes on the shore for the birders and showed about 30 people a view of the sky, planet, or pardon me, the moon, and a few brighter objects that we could look at. Nice event.
Great. That's awesome. It's nice to get back out and actually do some events, isn't it?
It's great.
Yeah. Excellent. Great. Thank you. Okay, Kevin Wenkoff.
Hi. I've just, like others, have enjoyed the morning, the lineup of planets this last month has been very special. I have a nice deck in the backyard, sit on a chair, just kind of sit there and soak it in. And that's all I've really done, and listened in on the meetings and everyone else's experience and wisdom. So enjoying the sky.
You can't get away without talking about your observatory, Kevin.
And I watched the building of my observatory in terms of robins building a nest under it. And they raised their young, and the young are now gone. So I have no excuse. I can get back on it and start pounding again without disturbing them. That's next. The problem is I cracked some bones in my foot on the weekend. So that's my latest excuse not to work on it for a few weeks anyway. But I'm getting there.
You're not supposed to be kicking at the telescope or anything like that, you know.
No, I wasn't. I was kicking at a steel door while I was doing some beekeeping to try to open it. And I found out bones are not as hard as steel.
Oh dear.
Oops.
Oh heavens. Take it easy.
You live and learn. You live and learn.
Yes. John Booth.
You're muted.
John Booth. Is he still here? Keith. No. Okay. Leslie.
Well, I don't have any pictures to show, not yet anyway, but I did experiment with my GoPro, and the cottage was still there. And I was wondering, where are the gypsy moths? What happened to them?
Their time has come and gone. That was last year. Okay. Well, that's good. Well, hopefully we'll get to see some images. Okay. Malcolm.
Oh, hello. Testing 1, 2, 3.
We can hear you, Malcolm. You can show Kim images of your LDD moth caterpillars. You've got millions of them, don't you?
I took some, based on what you told me, I did take action in this earlier in the spring to get rid of all the eggs that I could, and that seems to have made a difference. But I don't have 0 gypsy moths. I can say that. Should I share my screen there, Kim?
Yep, go ahead.
All right. So I'm going to show you a photo of a sharpless object. This is a SH25. I believe it's Sagittarius Scorpius area. I'm sorry, I didn't realize I was going to have to talk about a photo. I'm happy to share this photo though. But the interesting thing here is it's a region of, it's not a like very bright nebula, but there's some good nebulosity here, and that was kind of what attracted me to taking a photo of this area. So it's about a 2-degree field of view square. The interesting thing is I did not know that that there was a planetary nebula in this field of view, and I'm much more happier that I got that planetary nebula in my shot than I am actually of the shot itself. But I did a little inset so you could get an idea of what it looks like. There are actually 4 stars in the middle there, strung out in a straight line. It's kind of cool. It's just I'm always fascinated by planetary nebula, and then in order to determine whether or not I'd made a discovery or not, I plate solved it and annotated it to see what PixInsight would tell me about this thing, and it's an NGC object, so it's 6337. And while I'm at it, this is an image of M104 taken from down south. And I've got one more I can show you, I think. M22, hot off the press. I'm still processing this one, but that's it for me. And I've, like others, I've been, I saw Mars and Jupiter when they were at closest position to one another, and the lunar eclipse. And yeah, keep them busy.
That's great. Now that first image, was that taken here locally? You're muted.
Yeah, thanks. All those deep sky shots were from down south.
Okay. Thanks. Okay, up next, Mark K.
Hello.
Hello.
I don't have anything to show specifically. I have some questions I'd like to ask, but we'll do that after everybody's done there.
Okay, but you're showing the moon. That's good.
Yes, yeah, it's sort of hazy clear here.
Yeah, same here. Same here. Okay. Mike Haynes.
I don't have anything to show, and the last time I observed was pretty much for the lunar eclipse, and I haven't been able to get out. Between the mosquitoes and the weather, I've stayed in the house pretty much, so at night. That's about it.
Okay, thanks, Mike. Okay, Mike Lalone. No. Right there. Okay, Rosemary.
Haven't done much. I sat out that night, when was it, May 30th, that meteor shower. And I saw about 8 of those supposedly fancy meteor. A lot of them were just like psh, 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 the little ones. There was one good one. And I didn't bother setting up the camera because it wasn't going to pick them up. Other than since the eclipse, about the only observing I've done is like 2 o'clock in the morning when Carrie drags me outside, and there's been some beautiful clear nights, but I have just been from the gardening and opening beaver dams and stuff. By the end of the day, I'm so tired that I don't want to drag the camera gear down. But I am out there anywhere between 1 and 4 o'clock in the morning when she drags me outside every night. And there have been some beautiful clear nights when I was thinking of Steve out there running his camera. But like I say, I've just been too tired. So I've been spending a lot of time chasing moths because this is the time of year when you get the big cecropias and the Io moths and stuff. And I've got a black light at the window. So I've been spending time with those. But the meteor shower was the biggie lately. And that's about it.
Okay, thanks. Okay, next up we have Stan.
Had to unmute. Yeah, it was kind of funny. You guys had, hi, you guys have dark skies these days. So when you come up to the 50th latitude, we don't. So we're in that period of time that we don't actually have truly dark skies. So stick more to things like watching the moon and such. I did get some shots of the total lunar eclipse, but the only time that it actually cleared here was just when it went into totality. So I think I put one of those onto the national list just to see on the national Facebook page to see how many people had clear skies. And I don't know if it worked out well for too many places. The other thing is that's my observatory in the backyard. And Mark K is the one who kind of drove me to have something like that in the back because it's so convenient, especially when you get elderly. You know, at the end of the night, you kind of close it down, go into bed right away. You know, you could take your equipment apart tomorrow. I am just now trying to get a setup based upon stuff that Hank's been doing. I'm trying to get a new setup going inside there so I could do my solar work, both white light and that. But the problem is, as when you play with multiple cameras and multiple softwares, it takes you forever to try to figure out what you want. So still working there, but you know, every time I watch Hank, I get encouraged to continue. So that's why I keep coming back to this Kingston Center sessions.
Excellent. Thank you. That's great. All right, Tessa.
Hi.
Hi.
No pictures. I'm technologically challenged, so I won't be taking any pictures. I watched the lunar eclipse, and really, other than that, not very much.
Oh, that's good though. It's good that you got out. Are you seeing any more light pollution in your area with at the east end of town?
Oh, slowly up is definitely deteriorating the night sky. That's for sure.
Yeah. Yeah. Okay, that's great. It's great to see you, Tessa. Thanks for coming. Okay, so I think that's no, let's see. Richard Wagner.
Well, I don't have anything specific to show, but I was thinking earlier about what an awful month it's been for weather and terrible observing in May. And I actually got 15 nights observing in, so I'm not complaining anymore. June has not been such a great start. I've only got 2 nights so far. So.
Okay, next up, Kevin. Cal.
We have more than one person with the same name over and over again. You got to remember that part. It's really tough to remember what I've done in the last month or so, just because there have been so many things. So the big meteor shower that never happened. This is the night of May 30-31, and we had 7 events going on there. And then the night of May 31, June 1st, we had 10 events on the All Sky 2 camera, and none of them were spectacular. None of them, the numbers weren't there, the brightness wasn't there, nothing. But, you know, what can you do except keep looking? Somebody was asking about aurora, and I'm just going to say that the last time that we've had, no, let's not do that right here. The last big aurora that we remember is in 2014 September. And if we just go back, this is our list of aurora shots, and that's the best one so far. going back in time, there were some, little minor ones on the horizon here and there. And I don't think we got pictures of the one that went over the zenith. No, just regular stuff. These guys that live up in the 51st latitude, those Winnipeggers, they get this so many times every night that they don't even look up anymore. And here it's a once in a year or every few years occurrence. So anyway, that's about all I got.
Excellent. Thank you, Kevin. I have been doing solar, but I don't have anything processed. I tend to take them and then I'm outside doing other stuff and have to come in and do processing on those rainy days. So I was looking at one of the ones that I took today and looking at the prominence that was just hanging out there off of the north of the sun, and it was quite nice. But that's for tomorrow. I'll send that to the list tomorrow. So that wraps up our observing reports, and I'll just go over for what's going to be happening coming up, since we're not going to be having a meeting in July or August. September meeting. We're going to have Andrew Godfroy is going to speak on the 60th anniversary of Alouette. So we take our summer break. Again, we'll be at Lake Ontario Park. So come on and join us and talk astronomy. We are still looking for volunteers to run our Zoom social. Give Susan a break. And you can check out our website, kingston.rasc.ca. We're on Facebook and a Twitter, and also check out on YouTube. Tonight's meeting is being streamed live and it will be there shortly. And so this is the official end of the meeting, and I want to thank you to those who are on YouTube and those who came to sit in on our meeting from across Canada. And it's great to see you all, and I hope you all have a good summer. And